Okay, so recording started. Hi, Hilda. Hi, Harriet. Hi, Isaac. Hope you're all doing well. So, think everyone should know me here. My name is Paulina Makira. I'm a technical trainer, and today I'll be taking you through architecture with regards to the AWS Solutions Architect Associate exam. And when we talk about architecture, we have different types of architectures that are available. Sometimes we'll talk about the three-tier architectures. We have serverless architectures and so on, and many other architectures you can build in the cloud. So my focus on today will be basically on the serverless architectures that we deal with when we talk about AWS. So our discussion will be around AWS integration and messaging, especially when talking about serverless or also decoupled architectures. So the services that I'm going to be discussing today are SQS, SNS, Kinesis. But apart from that, we'll also be talking about the step functions and how they help us build. Also, one architecture which is very common, event-driven architectures in the cloud. But all these will still be under some sort of serverless technologies. So I'll go ahead and start with serverless before we dive into some of these services. So what is serverless about? And this will be familiar to you. We are describing services, but not only services, we are also discussing like, okay, services, some of the practices, and some of the strategies too that you can use to build like more agile applications, more fast applications. We want to respond to changes faster. We want to innovate faster. And that means that we are trying to avoid this work. If we want to be more agile in our businesses, we don't want to work on managing infrastructure. We don't want to do things like patching. We don't want to do things like capacity provisioning and so on. So we can focus on actually writing the code that is going to serve our customers better. So some of the advantages you can see when we discuss serverless as a form of architecture. Yeah, we don't have to provision any infrastructure, no servers to provision, operate, or patch. We can scale automatically by unit of consumption rather than server unit. And this is what we scale by when we talk about EC2. So instead of scaling in terms of servers, we scale in terms of consumption. So we can scale, for example, in Lambda with regards to the RAM we are using, and then pay as you go. That is the consumption-based pricing. You pay for value billing, consumption, you pay for what you have used, basically, pay for what you use or pay as you go. And then with serverless architectures, you're getting built-in security, built-in high availability, built-in fault tolerance too, because this is responsibility for AWS. It's built into the services themselves. And now I'll draw out a question to the team. This is serverless. What are some of the serverless services you know of? Which services in AWS will fall under the serverless category?
Would have Lambda.
Okay, I hear Lambda. So this is under compute. Any other?
DynamoDB.
So under databases, I hear DynamoDB. Any others? You can just unmute. You are allowed to say more than one. uh, any other services that fall under serverless? Come on. They can't be only two.
We have API gateway.
So we do have the API gateway, managing our APIs. Which other services fall under serverless?
Can we say S3?
So here is three under
Thinking.
storage. Mm-hmm. Too many to go. So we do have the SQS. So under integration and messaging, SNS too. Any other services that will fall under serverless? We do have event bridge. Okay. Okay, so you gave me like 6. So we have lots and lots of services that will fall under the serverless portfolio. AWS like provides this set of fully managed services that don't require you to provision, maintain, or administer servers. And under all the categories, so under compute, you mentioned Lambda. You didn't mention Fargate, but you remember this for serverless containers. Uh, you did mention API gateway. If you want an API proxy storage, yes, S3 is part of that. Databases, we have DynamoDB, but we also have Amazon Aurora Serverless coming into place. Amazon Cognito, when we talk about authentication, also falls under serverless. Jacob mentioned the ones for messaging services that are available. SNS and SQS are part of that. Today we are covering step functions as part of orchestration, and also we are covering kinesis as part of analytics. So I had already given you like a clue when I mentioned what services you're going to cover today. And Amazon Athena is serverless to do some queries on our S3. So today, like my focus will be more on SNS, SQS, step functions, and yeah, kinesis and Amazon MQ, which is not serverless. I'll just mention it as part of the messaging services that we have available. So here's an example of just a serverless architecture representing a messaging application, working with some of the services you have mentioned to me. So this example, we are using API gateway to handle all the tasks which are involved in accepting and also processing our API calls. And then, for example, if someone does a post request, it's trying to put some data into DynamoDB, in this case, our API gateway is going to feed those messages into an application message queue. And the message queue has been built over here by the SQS service, where from the queue, we have our worker service, which is going to process those messages. So in this case, they are using some worker containers on Fargate because we are talking about a serverless architecture. So this queue is acting as a buffer between the calls from the users and our worker service, just in case our traffic like spikes up, it will be able to handle and put all those messages, and they can be processed way better from our worker service. So the worker service uses serverless hosting in Fargate, which will automatically scale with each new container. Because it's a post request, we are writing data. So the worker service writes the processed message into a DynamoDB table, which is also serverless. And if the write was successful, it's going to get like a response from DynamoDB, where the worker services can go ahead and notify the simple notification service, which is going to, we know we have different subscribers for SNS. is going to push an SMS notification to a user like your write was successful. So just a simple serverless architecture. And now I'll be diving into my discussion for the day. So from the slide you're seeing over here, if we want to deploy multiple applications, they have to communicate with each other. Frontend has to communicate with the backend. A service has to communicate with another service, and so on. And there are two patterns of application communication that will come into place. We have the synchronous and the asynchronous, which can also refer to as event-based. And you remember when I started, I mentioned event-driven architectures. How do we build them? So synchronous application, immediate communication, sometimes you might refer to it. So sometimes we have some monolithic based of type of communication happening, where if we have two services, for example, the buying service and the shipping service, after someone buys something, we have a communication with the shipping service to understand, for example, where is this user located? How are we going to send their product to them? With the synchronous communication, we have the application directly communicating with the second application. But with the asynchronous or event-based type of communication, instead of immediate communication between the buying and the shipping service, we have a queue that is acting as a buffer between our buying and our shipping service, where our buying service will send all the messages to the queue, and our shipping service are going to poll the queue to see if there are any messages available. So with the synchronous monolithic base of applications, if there is a sudden spike, lots of people are doing shopping. It's like Black Friday or Black November, and there are lots of spikes over here. Yet the buying service has to directly integrate with the shipping service, communicate, and get a response. This is going to cause a bottleneck. So in that case, it's better to do the decoupling of our application. And these are some of the services that will come in handy when we talk about decoupling. So we have the simple queue service, creating a queue. We have the simple notification service if we want to publish and subscribe messages and so on. And we also have Kinesis that comes in handy as a streaming service. And these services, first, they are serverless and they can also scale independently. They don't depend on our applications. Now, we are going to get started with the simple queue service. Yeah, from the cloud practitioner, you needed to know the bare minimum. You just need to, this is a queue service. But right now you have to know like more features with regards to SQS, way beyond just, it's a queue service and used to decouple of our application. So going to SQS, fully managed message queuing service, also serverless, as you have mentioned, stores all messages, very highly available, like all your messages are going to be stored in different availability zones. So we have that high availability. And you can also, we'll talk about this concept in a minute. Stores messages until they are processed and deleted. So we'll be discussing that. And from the diagrams we have seen before, it's going to act as a buffer between whoever is sending the message and whoever is receiving the message. So over here, we'll talk about this way better when I introduce a feature called visibility timeout in the simple queue service. So we have an example over here. The producers, it could be an application, it could be a service. They're going to send the messages to our queue, and the consumers are going to poll for messages. And these are some of the terms you need to be familiar with. Prod consumer, publish, sorry. So we have publish, subscribe mechanism, but this is SNS, producer, consumer. This is SQS, mechanism of communicating. So just going deeper into SQS. So apparently it's one of the oldest offering given by AWS, over 10 years old, fully managed, used to decouple. And over here you're seeing we are talking about the standard queue. What is the other type of queue in SQS? We have two types of queues. What is the other type of queue? You can unmute, you can put in
Do
the
you think
chat.
we have FIFO?
We do have the FIFO queue. Well, thank you. So with the standard queue, what are some of the attributes that we get? Unlimited throughput. So you have unlimited number of messages within a queue, unlimited throughput, more of messages that can go through the queue. The default retention of messages. Now, these little details, that is where now the CSA comes in. Needs you to know these little details. In Cloud Practitioner, maybe or maybe not, you didn't need to know how long a message is going to be kept in a queue. But because the CSA will give you a scenario, you want to store a message for 30 days. And you know very well, they're talking about all things decoupling. And you know very well, like SQS, maximum days of storage is 14 days. Then, for that specific scenario that that person is seeking, SQS definitely is not the right service to go for. They need to put their messages somewhere else. Maybe they need to go to S3 and store them. So you need to know these details about what is the retention period. By default, it's 4 days. A maximum of 14 days, your messages are going to be stored in the queue. The standard queue offers us very low latency. Another keyword you need to remember is the limitation of the message. So the message can only be 256 kilobytes in size for it to be stored in SQS. The exam will try test you, confuse you, tell you they have a message which is 1 GB. That message you cannot use SQS as it is to store it there. We have other mechanisms whereby you can store that message in S3 and like put a, can I say something like a link? So the SQS, instead of containing the whole message, it will contain the link to the message in S3. So those are some of the architecture, that's what we're talking about, architecture today. Those are some of the architecture patterns you need to be aware of. So know that limitation of 256 kilobyte, retention period, and so on. And with the standard queue, we can have duplicate messages. I'll discuss that better. And also, we can have out of order messages because we go with best effort ordering. So if you want like the correct order of messages, that is when we go for the FIFO queue, which we'll be discussing in a moment. So remember all these limits that I've been talking about so that they help you, especially in your exam. So SQS, producer and consumer. The producer is going to send a message to SQS. The message is persisted in the queue until a consumer who is somewhere here processes the message and deletes that message. We have the message retention period. I won't go over that again. So an example over here, we are sending an order to be processed by a consumer service. So the details have the order ID, customer ID, and different attributes. This is within the standard queue, so we have unlimited throughput. The consumer could be running on EC2, but that is not serverless. It could be running on Lambda. If you want a serverless architecture, it could be running on Fargate, who is doing the processing of the messages. They are going to poll. So you have to have that idea, polling mechanism. SQS does not push messages, that is SNS. So these keywords are very important, especially when it comes to the exam. The moment a message is in this queue, it will stay there. SQS will not send the message to the consumer. It's the work of the consumer to check, is there any message in the queue, and process that message. And then once it pulls the message from the queue, processes that message, it's going to delete that message from the queue so that it is not processed twice. So that is the first thing I said in the first slide where I was like, stored messages until they are processed and deleted. That is how SQS work. And if I give an analogy, I don't know how the different countries work, but on my end, if we go to buy pizza and we go to the pizza shop, so what happens is, me as a customer, I'll go and interact, for example, with, I don't know if it's the cashier or what we call them. And there are many different customers, especially on a day we call Terrific Tuesday. So I'm not sure if it's the same everywhere. So in Terrific Tuesday, when you go to buy pizza, you get 2 for 1 price. So on Terrific Tuesday, there are lots of customers coming in. So what happens? We speak to the cashier. I want a chicken tikka. And what the cashier will tell you is, okay, I've received your order. You can go sit somewhere for 15 minutes or something. We'll call you. And we have the person preparing the pizza. Maybe they're the chefs in the bucket. So the cashier does not go and directly talk to the chef and is like, you know what, I want a chicken tikka, and then stands here till the chef prepares the chicken tikka and comes back with my pizza. No, that does not happen. This is what we call the monolithic or synchronous communication. What happens instead is I go, give my order to the cashier, and then we don't have a very good queuing service. What happens is there is a nail on some wall, and the cashier will go and take that is it a script, and put it somewhere on that nail and arrange them in order on that specific nail. And this is what I'm talking about when we talk about a queue. So the cashier is taking my order, placing it somewhere, and takes the next order from the next customer, place it on a queue, next. And that means that even though the people who are preparing the pizza in the background are few, there is no backlog happening on the front end side. The cashier is just taking orders, the customers are going doing something else and waiting. And now the chef will come and process the order from the queue. When I mean by process, it's just they're taking that order, working on it, bringing the pizza back, and going to the queue, taking the next order. So now we are having a decoupled architecture. And what is happening is, once the chef has taken this order from the queue and works on it and prepares it, the chief will come discard this paper you have over here. And that is the same after a consumer has processed a message from the queue, they're going to delete that message and work on the next one. Done, delete it from the queue, remove it, work on the next order. So I think that is also just an example of how SQS works with producers and consumers. And with SQS, you can have multiple consumers who can process and receive the messages in parallel. So the message can be sent, same message to the first server, the second server, the third servers. And at least once delivery means that the message can be delivered more than once. And I'll explain that in a moment. And because it's standard, best effort, message ordering, A, B, C, D. So it has to be processed A, B, C, D. But this is with FIFO, with best message, best effort ordering. It could be A, C, B, and D, where C is processed before B. And we can scale consumers to improve. That is one metric you need to be aware of. A common exam question too is this architecture we have over here, whereby we have our EC2 instances behind an auto-scaling group. The instances are polling for messages from a queue. One metric that our servers can scale on is the queue length. This is a CloudWatch metric you can set up, whereby our servers scale depending on the number of messages on the queue. And that is like a CloudWatch alarm you have to set up. Okay, so that is something you need to be know of, something you need to be aware of in an architectural perspective. You can make your auto-scaling group scale based on the number of messages in an SQS queue. And I think it's a very common exam question. Set a CloudWatch alarm, for example, if the number of messages are 1,000, scale, add more servers, and so on. So that is how SQS works to decouple between different application tiers. It could be also the front end and the back end, and we have a queue acting as a buffer. So here's an example of like a producer application which is going to create different customer orders, send them to our SQS queue, which is managing the messages in the queue, and then the consumer application is going to process the messages from our queue and then record the messages into an RDS database. So if a message cannot be processed, what will happen is something you need to be aware of. The message is sent to a dead letter queue. So where they are going to be processed later. So what you are getting over here, first, loose coupling or decoupling or asynchronous processing. We are getting fault tolerance in case our application is not able to process the message, it redirects the message to the dead letter queue. That is the fault tolerance you are getting. And also, if we get a demand in spike, so here they're talking about absorbing spikes. Amazon SQS can make our system more resilient. So in case there are lots of messages coming in from front end, they're just being stored in the queue, and the back end can scale depending on the number of messages on the queue, so it's able to absorb those spikes. So just more information about architectures, I'll share some links on the chat. Um, so like an application similar to what I have been showing you, for example, this one, whereby we have like maybe a load balancer, we have the ordering, we have a queue, we have the consumers sending information to RDS in the backend, and in case messages are not processed, they are sent into a dead letter queue. You can learn more about the alarm that is used to scale over here. So all the information about a similar architecture that you can work on is here. So I'll just share this link. And also information about loosely coupled architecture and how to build the workflow. So that I'll share too. And then this one was a link I should have shared before on just some of the serverless services that we have in AWS. And you can see all of them being mentioned according to their different categories. Yeah. So you can save those links somewhere, especially, yeah, the first one, just to see like an example of a decoupled architecture, but I'll also do a demo on SNS, SQS, and how they integrate. So speaking of security, yeah, within security, we do have encryption, both in flight and at rest, using KMS. And it also has like client-side encryption in case you want to encrypt your messages before you send them to AWS. That is an option that is available. We do have, you can set up access control using IAM policies. Jacob should have access to my queue. And we also have the SQS access policies. So from there, you remember the resource-based policy. And luckily in the demo, you'll see an example of me setting up a resource-based policy, which looks similar to an S3 bucket policy. When do we use resource-based policies? For SQS, for example, if you want to give cross-account access, common exam question, actually just from S3, SNS, SQS, if we create, how do we give cross-account access to our buckets? Through bucket policies. You can use IAM roles, I know, or bucket policies for cross-account access to S3. And I pose a question to the team. When would you use a bucket policy versus when would you use an IAM role? And the answer to that question will also answer this question over here of setting up access control for SQS. When would I use an IAM role versus when would I use an SQS access policy? Any trial. Both can help me give cross account. Jacob?
Yeah, so I would say that using IAM roles would be targeted if you're allowing users to access S3. That would make sense. But if you maybe dealing service application to application or service to service in AWS, then bucket policy would make sense.
So you say app to app, but IAM role would make sense for S3 cross account.
No, I'm saying IAM roles would work for if you are dealing with a user, like you have
User.
users. Yes, yes,
Okay.
yes, yes.
But don't we use IAM roles if we want EC2 to communicate to S3? Again,
Yes, yes, that would, yes, you still use roles on different services. But I'm just saying that the use case where a policy may make sense would be for that use case, yes.
Okay.
Yeah.
Okay. I'm making it more difficult, Jacob, because bucket policy, I know, like if I want, for example, I'm in my AWS account, I want you, Jacob, to have access to my own S3 bucket. I can create an IAM role and give a trust policy that allows Jacob to access my S3 bucket. That is cross-account access. But I can also go to the bucket policy. And remember with the bucket policy, because it's a resource-based policy, it has different things. Like we have the common here, effect, action, and resource. But in the bucket policy, I can also add a principle and
Yeah.
specify, like Jacob is allowed to.
Yes.
Uh,
Yes.
so this both is possible, right?
Yes.
For cross-account access. But what is the difference?
The difference is with the policy, for example,
Mm-hmm,
that the one you've highlighted, where you have like a principle, you
mm-hmm,
have more fine grain. But when it comes to roles, it's bundled. Like there are those which are AWS managed, for example, which are bundled, like can give you S3 full access. That means
mm-hmm.
anyone who has access to that role will have all those rights. But for the policy where you've defined it, you can be fine grain and say you're only giving Jacob to do ABCD, put or do a specific action. Yeah,
Okay.
that's I would say the difference.
Okay. But I can create a role and attach it a custom policy, can't I? I don't have to use the managed policies. So I know both both ways work. The major difference, and I know I went out of topic, that is some form of IAM topic. The major difference between the two is how access works. You know, with an IAM role, if it's a user, you're going to lose all your previous permissions. So if I gave you a role, I said, let me now disturb someone else. I said, Harriet is trusted to assume a role within my account. When Harriet assumes that role to access my S3 bucket, Harriet is going to lose all her previous permissions as Harriet, and now is accessing my account as the role I have created for Harriet to access my S3 bucket. This only works when, for example, I want Harriet to view maybe some data in my S3 bucket, and that is it. What if I wanted Harriet to come into my bucket, or for example, copy data from her bucket to my bucket, or copy data from my bucket to her bucket, or access my bucket and maybe, do some compute on her end? The role will not work, because once Harriet has assumed a role, she loses her previous permissions. So if she needs access to both environments, she needs access to both her account and at the same time needs access to my account, whereby, for example, taking an object from my bucket and copying it to a bucket, which is in her other account, and make it work, that is when the bucket policy would come in. With the bucket policy, you can access another account and not lose access to your own account in case maybe the compute is happening in my account, but the storage is in another account and so on. So yeah, what you have been saying are all correct, but I think that is one of the major differences which would make you decide whether you want to use like a resource-based policy for a resource or attach an IAM role to that resource. So yeah, from my own perspective, but you can also dig further on that. So yeah, back to SQS policies. So processing messages from our SQS, especially for cross-account access to SQS queue, you can use bucket policy. But yeah, you're not limited to creating a role and attaching to another user. It's just that if you attach a role, it will work as long as they don't need to do anything in their own account. But if there is some integration that is supposed to happen, we can use the access policies. Okay, so the queue types, I have already discussed: standard, unordered, at least once delivery. You mentioned we have the FIFO, first in, first out, whereby this is used when you want to enhance messaging, where the order of operations is very critical and you don't want any duplicates. Duplicates cannot be tolerated at all. So, and for that, we have very limited API calls per second. So depending on how the exam questions comes about, maybe you want unlimited API calls per second, then you'd have to go for standard. The FIFO is limited in this case. And you can see like the throughput. So just some key things you need to know about. The throughput, you have 300 messages per second without batching. And if you put batching where you're bundling multiple messages together, you can have up to 3,000, and that is the limit. And the message is sent exactly once, so we are removing duplicates and messages are going to be processed in order. Other things you need to know about SQS: visibility timeout. A question on visibility timeout will come into the exam. What is the visibility timeout? Now, we have the producer who sent the message to a queue, and we have the consumer on this other end who is processing the message from the queue. What happens? When the consumer comes, pulls the queue, gets a message, and starts to process it, that message becomes invisible in the queue. That means that if I had EC2 instance 1, 2, 3, instance 1 came, checked the queue, saw that message, and took that message back for processing, that message will become invisible so that instance 2 does not go ahead and process the same message. So the visibility timeout is the time where a message is pulled by a consumer and it becomes invisible to other consumers. So by default, this timeout is always 30 seconds, and we'll see that when we get to the demo. And that means that the message has 30 seconds to be processed. When our visibility timeout is over, like that time the message is invisible, the message will become visible to the queue again. And that means another consumer can see that message and try to process it. So after the visibility timeout is over, the message comes back to the queue. And that is exactly what makes like messages being processed twice. Because you set up a very low visibility timeout or you put the default, but the consumer took more than 30 seconds to process that message and delete it from the queue. That means that 30 seconds passed, the message became available again, and consumer 2 retried to process that message. That is what happens and makes like your message be processed twice at some times. So this is a setting that you have to optimize. That's what you're saying. This is about optimizing your Amazon SQS queue configuration. It's your responsibility as the developer to figure out what is the best visibility timeout depending on how long the consumer will take to process your message. So default 30 seconds, the consumer is going to delete that message once it has processed it. And if the consumer fails to delete that message, when the visibility timeout is over, the message will still be available in the queue and it can be processed again. So typically, if you're building your application, this timeout, you have to set it to the maximum time that is going to take your application to process and delete a message from the queue. If you set too short of a visibility timeout, your message is going to be processed twice. And if you set too long of a visibility timeout, it's going to actually even delay subsequent attempts of processing a message. So one feature you need to know about when optimizing your SQS configuration. The second thing is choosing the right polling type. I wonder if anyone can like explain to me what is the difference between short polling and long polling. And the diagram might explain a lot too. So you can come in. What is the difference between these polling types, short polling and long polling? Oopsies. Anyone, any trial?
Um, so if I try to guess from just the names, the short polling would be like the frequency at which the timeout or the time allocated for the message to be invisible is shorter. For example, if we say for short polling, maybe we do 40 seconds. Then long polling, we could say we do a minute.
Okay.
Yeah.
Thank you, thank you, thank you. Any other view? That's Harriet's view. Gerald.
I believe short pollings whereby each and every after every, I won't even say after every second, 0 seconds. So we have you check the queue to see if there are any new messages in the queue every time. But long polling, you set a duration between 1 to, I can't remember, 25 seconds. Long polling, you set a time frame in which you're going to check if there are any new messages which are in the queue. But for short polling, you check every time ensuring that there is no new messages that's there, and they are processed.
Okay. Okay, so that is Gerald's view. Jacob, I saw your hand up.
I think Gerard has put it perfectly as I wanted to put it. So yeah, that
Okay.
short pulling is where there is no time to wait. Like you have to just keep checking, and then for long pulling, that's where you give up to maybe 20 seconds or 30. Yeah, so that you can momentarily check in that interval. Yeah. So he was on point.
Okay, cool. So these are other parameters for optimizing our queue. So this polling, whatever, is not related to the visibility timeout at all. So with the polling, short polling, we have our queue over here and we have our consumer. And I like to put it at an analogy as how different people receive salaries. So if I think about, okay, for me, I think I use short polling, especially when you have like message delays, and let's just say you don't get like a message when you have received your salary. So you have to check your bank account. So with short polling, every single like second or 0 seconds, Pauline will be like, as the consumer, because I am polling the queue. It's not like I am getting messages from the queue. I'll be like, are there any messages? Is there my salary? And then I'm going to get a response back. For example, if it's there is, I'll get one. If there is no, there will be 0 messages in the queue. And every like 0 second, I am polling my bank account to see if there is any money there. And that means that we are going to, me as a consumer, I'm receiving a response immediately, providing a faster response. In case that next time I poll and there is money, I'll get immediate response. But that means that we are increasing the number of responses we are getting from the queue. But that means that we are also increasing the costs for receiving those messages. With long polling, we set at least, I think it's 20 seconds max, does not return a response until at least one message arrives. Like if a message arrives over here, we are going to like get a response. Or we are not going to get a response at all, at least until the timeout period or the poll times out. So this means that, so these are now the likes of Jacob who are demure. So they'll check in the morning, and maybe they have set up like they'll check the account balance. Okay, I'll just wait, for example, like 12 hours. If I won't have received a message, then I'll go ahead and like poll again my bank account to see if there is any money. So you have set up a period of a timeout before requesting, getting a request, sending a request to the SQSQ. So what happens over here? We are getting less frequent response, but also we are decreasing our costs. So depending on the exam question, if they tell you something like cost effective, I know you know those terms by now. They're thinking about short polling, long polling, and I know the answers will be like paragraphs trying to confuse you into which type of polling the client should use. If costs are a concern for this particular client, you as a solutions architect would rather prefer long polling for them because there are less responses coming from SQSQ, and that means that you're going to pay less money. So depending on the frequency of messages that are arriving on your queue, many of, like if you are using short polling, many of the responses we are just reporting an empty queue because you'll always get a response, like it's 0 messages. So unless your application requires an immediate response to all its poll requests, long polling is actually preferred compared to short polling. And these are settings you set up. So I have explained the visibility timeout. If a message is not processed, it will be processed twice. You can use this API call, make this change message visibility API call to get more time. If the timeout is high and our consumer crashes, reprocessing is going to take time. But if the timeout is also too low, like seconds, we might process our messages twice and get duplicates. Short polling, by default, we use short polling because we poll our queue every 0 seconds. This is by default. So when you set up long polling, you are setting up a consumer requests. When a consumer requests messages from the queue, they have to wait for message to arrive. If there are none, that is long polling. We are reducing API calls to SQS. And you can see the timeout period is between, like, not timeout, that long polling period is between 1 second to 20 seconds. Those are the settings you can set up. And this is always preferred compared to short polling. So, yep, I think I have explained all these. I think these are just like slides I showed before. how SQS queue works and how SQS is used to decouple between the front end and back end. And just to wrap up on this, some of the use cases, creating work queues, just the decoupling aspect of it for our distributed application. You can either choose a standard if you want unlimited throughput or FIFO if the order of operations is very important. You can use it as a buffer to perform buffering and batch operations. And this is where you are adding now some form of scalability into your application and also reliability into your architecture. So where even though messages come in a lot, we'll be able to scale and we won't lose any messages. We can use it for request offloading. This is now where the dead letter queue will come in, move slow operations off to another queue or to another path. So we are doing some enqueuing of slow requests so that we process the other messages and then we can come back to this one. And then auto scaling, I already mentioned this. You can use SQS queue to determine how to scale. So for example, if you combine like that scenario I showed you before, which is a common exam question, if you combine auto scaling with EC2, you can scale depending on the number of messages in the queue. And as a solutions architect, you should not always know it's about trade-offs. It's important to know like which technology is best for which use case. And with messaging, we have like different patterns that can come into place. So when do we use queues? Service to service communication, like Jacob put it before. If you want a service to communicate with another, you can use SQS queue. Asynchronous work items. So if you need like, if your application for some reason needs like synchronous communication, we don't use queues. So asynchronous. And for example, if you want state change notification, in case this happens, maybe an EC2 is shut down, blah, 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 send a message to this, we can use the SQS queue. When do we not use queues or message queues? You want to select specific messages. No, all messages are going to be sent in a queue. As long as you have set with the producer of the message, any messages that producer is going to produce are going to be sent on a queue. So you can't do a selection of which message will be processed by which server and so on. If you want to select that, you would go for a different service for that. And then if you have very large messages, you remember we had a maximum of 256 kilobytes. We can go for the message queue. So Jacob, your question is going to be answered in a moment when we look at the other different services like RabbitMQ versus SQS. So yeah, the likes of, I think it's just about how SQS is managed and fully managed by AWS, and being serverless, you don't have full control over the infrastructure. They work the same way, but now AWS provides us with another service like the Amazon MQ, which I'll discuss, where, for example, if an organization was using like RabbitMQ and all the other types of queue types, all the other types of open source or non-open source, and they want to use the same in AWS, they would go for like Amazon MQ service. So we'll discuss that when we get there and see how it is different. But it's a message queue, like, yeah, the RabbitMQ you're talking about. Okay, so I'll quickly go over SNS and then we can do a demo and then take a break and then come back and now work on Kinesis and the rest. So SNS, you all told me it's serverless. When do we use SNS? We want to send one message to many receivers. Like, for example, now we have a buying service and maybe we want to send that information, maybe an email notification to someone, and then send that same message to the fraud service and the same message to the shipping service and maybe the same message to another SQS queue. So you want to send one message to many receivers, we use SNS. Now this is not producer consumer based, it's publish subscriber based, whereby the buying service is going to publish a message to the SNS topic, and the SNS topic will send that message to its multiple subscribers. And that brings me to a question back to the team. Subscribers. What are the different subscribers for SNS? What can subscribe to an SNS topic? We do have email. So with the phone number, that is SMS. Any other subscribers? And Hilda?
HTTP and HTTPS.
So the HTTPS backends. Another answer is just on this slide. Okay, so the different AWS services. But is it all?
No, not all. There are specific services.
Which ones?
So for example, notifications. So for example, I can send some notifications either to maybe like EC2 if it needs to receive something, or if there is a confirmation that needs to go to some other serverless services. I could interconnect basing on the use case.
Okay.
Yeah.
My question is, can EC2 subscribe to a topic? Like, I know, okay, the integration is there. For example, like all services, literally almost all services can integrate with SNS, but in a way that they act as the publisher, like S3 event notifications sent to SNS. But can we have S3 as a subscriber to SNS, a topic?
I don't think they can subscribe directly.
Mm-hmm.
You have to use intermediates where there is some like a Lambda or something like that receiving that, then sending it to S3.
Yeah, so that is what I'm looking for. So not really, yeah, AWS services, but they're specific, like Lambda can subscribe to an SNS topic, and then from there you do the other integrations you want. What are we have like 7. And I told you guys, one answer is in this slide. I don't know why you're not telling me.
Okay, SQS.
Yeah, we do
Then
have SQS.
then there is what I've used, which is IoT Core as well. Yeah.
Okay, so let's see. So we do have SQS, we do have Lambda, we have the KDF, emails, SMS, and mobile notifications, HTTPS endpoints, and so on. So especially this, now if you want all the other types of integration, you can use the HTTPS endpoints to set that up. So the producer is going to send message to an SNS topic. The receivers or subscribers, we can set up as many, I think up to 12 like million plus subscriptions per topic. And once a message is sent to that topic, it's going to be sent to all the subscribers. And now we can do some filtering whereby we send only a message with a specific attribute to a specific subscriber. We'll see that. So use cases for SNS, CloudWatch alarms, so you can receive immediate notification when an event occurs. So the event-driven form of architecture coming into place. So for example, there is a change in our auto-scaling group, blah, blah, blah. Send a notification to SNS. We can use SNS to push like targeted headlines to subscribers, for example, by email or SMS. And upon receiving the email, the readers can choose to learn more, for example, by visiting a website or launching a specific application. You can use SNS. And then push notifications, for example, updates, as you have seen over there. So you can send notification to an app indicating that an update is available, and that notification message can have like the link to download the update. So SNS integrates with a lot of AWS services, as I have mentioned. All the other services can publish notifications to SNS, but there are only few that can subscribe to the notifications in SNS to perform a specific action, literally a lot. So characteristics of SNS and especially what makes it different from SQS. So with SNS, first we have a single published message, and SNS also has like standard and FIFO, right? SNS will try to attempt the messages from the publisher in the order they were published, but it's not a guarantee. So if you want a guarantee of the order of messages as they were published, you'd go for the SNS, first in, first out topic, which will have strict message ordering and the duplicated message delivery and so on. No recall options. You cannot recall a message in SNS. Once it's delivered and that's it. The same way you send an email. You have sent an email, if you have a typo and so on, that email is already delivered. So we cannot recall messages within SNS. But with SQS, in case a delivery fails or a processing fails, it will come back to the queue and you'll have access to it. So when a message is delivered, there is no way to recall it. That is also another difference. We have different types of retry mechanisms. You can set up like different delivery policies, which is out of concept, but something you need to know of. We have different retry patterns you can set up if a message now is not delivered. No recall is when a message has been delivered, but if it fails delivery to the subscribers, you can set up like retry patterns like linear, exponential, back off, different types of delays. And then we do have the standard and FIFO topics depending on the needs you have. So how to publish, create a topic, the subscription, publish to the topic, and all the subscribers will receive your specific message. And for mobile applications using SDK, you create an application, an endpoint, publish the message to the endpoint. So now it's not topic, and then it works with all these other integrations that you have available. Security, similar to SQS. Encryption in flight and at rest using KMS, in flight using the HTTPS API, TLS, and you can set up client-side encryption. Access controls, you can use IAM policies or the access policies, still similar to SQS. And we have this architecture called the fan-out architecture, whereby you can have a same message sent to different SQS queues, and the consumers for those queues are like different types of servers. So for example, an online order is received, the message is sent to SNS, and then fan out to two queues. So the first queue, the consumers do the processing of the order, and the second queue, the consumers do the analysis of the order. So that is an example of an effective way of distributing messages to different microservices in this case. So same as you can see over here, a buying service. So the first queue, the consumers are doing some fraud detection. The second queues, consumers are related to the shipping service. So push once in SNS, receiving all SQS queues that are subscribers, fully decoupled architecture. And SQS is helping us with now the persistence bit, which SNS cannot. Data persistence, delayed processing, and retries. Those are now the benefits of SQS that are coming in handy within this architecture. And you can add more SQS subscribers with time if you need another form of service over there. And you need to ensure that your SQS queue policy allows for SNS to write to that queue. And one cool feature we are getting is it can even work with queues in other regions. So you have that cross region delivery of the messages. And also another architecture you can see over here. An event happens in S3. And now we do like S3 event notifications to an SNS topic, and then we fan out to different queues or even different Lambda functions. So for the same event type, we only have one event rule. And if you want to send that same event to multiple queues, you can do a fan out or even fan out to multiple Lambda functions. And yeah, this is also another architecture, SNS to S3 through Kinesis, data firehose. We'll discuss Kinesis in a bit, how the Kinesis is used to load data to different storage services or different destinations. We'll see the different destinations. So you can have SNS, send information to Kinesis, and then we'll have an architecture like this. Kinesis does the processing and then loads the data into S3 or any other destination that we have available. FIFO, first in, first out, ordering of messages. So, and we prevent duplication. So we do deduplication to remove any duplicates. And you can either have SQS standard and SQS FIFO as subscribers, and it has limited throughput. So those same things I talked about as an SQS FIFO, same. And now an architecture over here, you need three things: fan out architecture, ordering of messages, remove duplicates. How do you do that? You create an SNS FIFO topic and have the subscribers be SQS FIFO queues, and you will achieve that architecture you are looking for. One thing to note, with SNS, we have message filtering, whereby if a subscription does not want to get all information from your topics, you can create a filter policy. If we do not add a filter policy in SNS, the subscriber is going to receive all messages from that topic. If we do add a filter policy, for example, over here, a buying service, a new transaction has been made, we can set up like the first SQS queue, because the consumers in the background are doing like processing for the placed orders. We only filter for the messages that have the state placed. Second queue, we only filter for messages that have the state cancelled, and so on. So we can set up a filtering policy to determine like for the to specify like subscribers receive which specific messages. And literally that kind of wraps up the SNS SQS thing, just to see some of the differences available between the two. SNS, we don't have, the SNS messages are not persistent. SNS, you can do some retries if the message is not delivered, but once it's delivered, it's delivered. But with the SQS queue, we do have some sort of message persistence in case delivery fails. Delivery mechanism, SNS is push. Once a topic is created, it's pushed to multiple subscribers. SQS is poll. The consumer has to poll the queue to check if there are any messages available. So over here, we are talking about a publisher and a subscriber. SQS, you're talking about sending and receiving messages between multiple application components, but also you can talk about it in forms of producer and consumer. Distribution, SQS is one to many, but not SQS, SNS, one to many subscribers, we push the messages, but SQS is service to service communication, so it's more of a one-to-one mechanism. Now, the other that I'll just touch on is now the Amazon MQ service. So here is now the difference that comes in from Jacob's question. So SQS and SNS, these are cloud native. The same way we talk about if you want a container in AWS, you'll go for ECS, cloud native. But if you are running Kubernetes somewhere else and come to AWS, you'll do the EKS. So these are cloud native service, and it supports the traditional applications running from on-prem that are using these different protocols. And now if you are migrating to the cloud, you don't have to re-engineer the application to use SQS and SNS. Now we can use Amazon MQ for that, and it supports the Rabbit and Apache ActiveMQ. So, but the difference now, it's not serverless, does not scale how SQS and SNS would scale. It runs on servers. You can set up multi-AZ, like how we set up multi-AZ for RDS. And Amazon MQ, it's like a combination of both SQS and SNS. So it has both features of a queue, and it also has features of like topic features. So that is Amazon MQ. If you're migrating to the cloud and you don't need to re-engineer your application. So this is how the architecture looks like basically. So you set up like your brokers in like an availability zone, runs on servers. You can set up like the storage to use EFS because EFS will go across multiple availability zones. And now you can see this availability is similar to RDS multi-AZ, whereby you'll have the active broker and the standby in case the active goes down. So, yep. So I'll do like a quick hands-on on some of the features we have been talking about, SQS, SNS, and see how that works out. Then we'll take a break in the next like 15 minutes. So it's a very simple architecture, just building a serverless architecture using SNS, SQS, and using AWS Lambda. And just the objective of what we want to do. So we know what decoupling is about. And if you're talking about serverless, why do we replace EC2 for Lambda? So we are going to create an SNS topic, an SQS queue, and then create event notifications in S3. And then also create Lambda functions using like pre-existing code and invoke our Lambda function from an SQS queue. And then, yeah, if we get time, we can do some monitoring, see how we can monitor how it works. But if you take a look at the architecture, so let me just bring my whiteboard. Okay, so the architecture, we do have a user. Okay, so we do have our user who is going to ingest like an object into Amazon S3 bucket. And from Amazon S3 bucket, we can create like event notifications. So in case an object is triggered, send that notification to an SNS topic. And then with that SNS topic, we can subscribe to multiple queues. So this is SQS queue. So we are doing a fan out to different SQS queues. So Q1, Q2, Q3. And then all these queues will have like Lambda functions as consumers in the background. So the producer is SNS, the consumer is a Lambda function. Yeah, I think that is the so Lambda function 1, 2, 3. And what these Lambda functions are doing is just like either creating a thumbnail, for example, Lambda function 1, when that image is uploaded, create a thumbnail. And then Lambda function 2, so will be for the web version. If someone is using a web, how will the image look like? And then the third one is for the mobile. Like if someone is interacting with the app using mobile, how will they go about it? And then after all these Lambda functions create the images, they go ahead and upload those images into an S3 bucket. And then you can do check some logs using CloudWatch whenever the application works. So this is an example of the demo. Basically, the architecture of what the architecture of my demo is going to look like. So we'll see the different options. So I'll just start with creating our topic. So SNS. So we quickly create a topic. So you can see we have either FIFO or the standard. So I'll just go with the standard topic. And then I can say this is resizing the image depending on whether it's mobile, web, or we just want a thumbnail. So resize image topic. And you can see all the things you have set up. So with the encryption, it provides in-transit encryption by default and so on. So you can add encryption over there. Access policy, who has access to our topic? This is where you can set up like your access policy. By default, it's only the topic owner, but you can change this. So it's just similar to like an S3 bucket policy. Data protection, which sensitive data to monitor and prevent from being exchanged. You can set that up, either which one you're accepting, which one you're denying. So I won't be going into that. Delivery policy, I told you there are some sets of retries. So to retry failed deliveries to these endpoints. What is the number of retries? Retries without delay. So those are some settings you can set up in SNS. Status logging to CloudWatch logs, tags, and you can even integrate with X-ray for active monitoring. So I'll go ahead, create the topic. And we are going to need the topic URL. So I'll just copy this somewhere. I'll need that topic URL. So the next thing I'm going to do is create my 3 queues, the 3 queues that I'll be interacting with our Lambda function and who will also be our subscribers to these specific topics. So create queue, I'll choose the standard queue and you can see at least once delivery, no message ordering, best effort ordering, FIFO, fast in, fast out, exactly once processing. So my queue, this one will be the thumbnail queue. And these are the settings which you have been talking about. The message retention period, you can see the maximum is 14 days and could be anything between 1 minute and 14 days, but by default, it's 4 days. Visibility timeout is by default 30 seconds. You can change it from 0 to 12 hours. 0 seconds, basically, I don't know how that message is going to be processed. And then we have the maximum message size is 256 kilobyte. You can set anything between 1 and 256. And then we have the receive message wait time. This is now the long polling. By default, it uses short polling, whereby it's 0 seconds, and that you can set up anything between 0 and 20 seconds. If you change this, that means you're using long polling now. And then we have this feature called the delay. And this is just the time, like you can specify some delay for delivery of the messages in the queue or for the message to be available in the queue for being processed. So that is the delay. By default, it's 0, but you can set anything up to 15 minutes. So those are some of the settings you can set up to configure your specific queue. By default, encryption uses SQS key that is managed for you. You can set up access policies and so on. Read drive policy, which source queues can use this queue as the dead letter queue. Or you can set up a dead letter queue for this queue. In case processing fails, send them somewhere else. And that is basically the settings that you have for the SQS queue. So we have the thumbnail queue available for us. And then we can go ahead and subscribe this queue to our SNS topic. Why is it not opening in a new tab? Okay. So here is my topic. Under subscriptions, I can create a subscription and specify the protocol. You can see all these are what can subscribe to an SNS topic. So KDF, SQS, Lambda, email, HTTP, HTTPS, platform application endpoint, and SMS. So over here, I'm saying I want an SQS queue to subscribe to this specific topic, and then I can select the thumbnail queue in this case, and you can set up a filter, what I've been talking about, like which, if I set up a filter policy, I specify which attributes or what will the message body contain that this queue will subscribe to. But if I don't set up a filter policy, all the messages are going to be sent over here, and you can set up a dead letter queue for this queue. So I'll just go ahead, create a subscription. And then we can create like the 2 more queues quickly. So web queue and mobile queue. Same settings as before. And subscribe them to my resize image topic. Cool. So my three queues are created. Now the next thing from my diagram is to go to S3 and create event notifications whenever an upload happens. Yeah, send that information to SNS so that it will fan out the messages to our SQS topics that will resize our images. So I do have my bucket over here. And just before I work on that, I know it will fail if I have not edited the access policy. So for my SNS topic. So under this topic over here, under access policy, I need to edit it so that it allows S3 to send messages to it. So I'll edit and access policy, I'll just copy this I have. And you can see it allows deleting, publish, receiving messages from the topic SNS topic ARN, and the AWS account, I replaced this with my topic owner. So, and it's allowing who, you can see the principal is S3 service 2. Okay, so I'll get the topic ARN. And the topic owner, basically me. Mm, okay. So I'll also share this on the chat so you see what a policy is supposed to look like. Okay, so that is my policy all set. And save. So now back to S3, my bucket. And under properties, this is where you set up event notifications. So I'll create an event notification. Resize image event. And then you saw I had a folder called ingest. So in case any object is placed into there and it's a JPEG file, because we cannot resize like create thumbnails of PDF, that is what I want for it to look like. All object create events. So, and you can see the different types of events that you can set up to send notifications for. And then destination of the event is now SNS topic, which will do some fan out, and I'll specify the topic that I have. So as long as the policy I have set correctly, it should work. And it's going to like be sending my messages to like, yeah, the SNS topic. So the other thing pending now is the Lambda functions that will do the resizing and will be done. So create function. This will be called create thumbnail. From Python. So I'll just use an existing role for this lab. So that role should have like the permissions it needs to access both S3 and SQS. So, and then I'm going to add a trigger for my specific Lambda function. So, and the trigger of this function is going to be the queue. So over here, I'm looking for SQS. And this was the thumbnail queue. Batch size, I'll just say 1. So the maximum number of records in each batch to send to the function. And I'm going to add that trigger. So the code that I'm going to use, I'll just upload from my laptop. So now SQS is going to trigger my code. So there is this zip file that I'm going to add as the code. So while it's open, while it's uploading, I'll just show you some of the content that is available there. Okay. So it's just a simple function. It imports the pillow library for our images and then does the resizing of the image once it's uploaded from our S3 bucket. Yeah, so it's a very short Lambda function available over here. So What else do I need? So I'll just change the runtime settings to include my specific event. So you can see it's called create thumbnail .py. So I'll edit this. So it just gets like the correct handler to use. And then for the configuration, we can edit the description and also the timeout. So create a thumbnail sized image. And then the memory, you can see the maximum memory you can have and the minimum memory you can have, the ephemeral storage, and also the timeout. You can set up what is the maximum duration for processing. So I'll just add so that it's 1 minute just in case. And save. So that is our Lambda function. I can go ahead, create the other two. So this one is create a web image. Triggered by SQS. So web queue, batch size of 1. So I'll share all the zip files, no worries. So if you want to run this on your own, you can too. Mobile image. This one is for create a web-sized image. And I'll just increase the timeout to 1. And finally was the mobile image one. The trigger is SQS for my mobile queue. This one is to create a mobile sized image. And then the code I upload. And let me just share the code on chat. Seems like I can't. So Isaac, I think I'll share this with you and then you can share with the team. Can't seem to find the upload option. Okay. So that is my that function. All that just doing some sort of resizing and edit the handler. And now my three functions are created. So by now, hopefully, my architecture is looking like this. So we have a user sending data to S3. S3, we have set up event notification, which it fans out to three queues. The three queues have the consumers as Lambda functions. And now it's just waiting for, if I upload an image to S3, if I have set up everything correctly by now, the functions should be able to do the resizing as I need. So I'll just download an image. And upload an image to S3. So S3, I want to upload an image. How did I save it? Just a minute. So this is the image. Sorry. Okay, here it is. So my image is uploaded. And now I have to validate that the files have been processed. So if everything went on correctly, let's see. now you can see like the 3 folders have been created. That means that my architecture worked correctly. The Lambda functions, the notification was sent to SNS, fan out to SQS, to the different Lambda functions. And now you can see like my mobile, I should have like the mobile version image. So I can just, okay, it won't open. I can just download that. So they should be different sizes now. So that is the mobile image version. This was the original. This was the original. You can see the mobile image is a smaller one. If I go to the web image, you'll see that. Okay, kind of a bigger one. And then the thumbnail. So you can see the thumbnail is also a smaller one. So our architecture worked out correctly. So that is how you can use SNS, SQS, integration with S3 event notifications. And then, yeah, if we had time, we would view the logs in the CloudWatch to see what exactly Lambda was doing and so on, and all the executions, the build duration, and so on. We can see all of them. So that wraps up the first part of our section. Any questions? If there are no questions, we can take a break, come back, and then do the second part on kinesis and step functions.
Okay, thank you, Pauline. So friends, let's take a 10 minutes break. Shall be here at 11:56.
We can just do 12. 12.
Okay, yeah,
Okay.
it was long. All right,
Yeah,
so
Jacob, please, you can come in before we go for the break.
Okay, maybe just the question you'll look into is around the A3 notification. Yeah, maybe just something that it's not like a question, but just a supplement that S3 notifications sometimes have a limitation where if you if you send if you're setting up an event notification, it can only allow you for one notification. You can only set one rule. So if you want to set maybe multiple rules, you may have to use event bridge.
Yeah, absolutely. Thank
Yeah.
you for
So,
that.
okay.
Yeah. Okay then. See you in 13.
tuzivuge tuzitwalekeyo omutima bagukubanja buli kadde kinnawolovu ontambuliranga kinnawolovu kinnawolovu kyova olabanga ndi musanyufu kinnawolovu onvimbiranga kinnawolovu kinnawolovu kyova olabanga ndi musanyufu bw'oyagala kunaaba amazzi bakuwe bw'oba toyagala bakuleke bw'oyagala kudoola gosita kuwe bw'oba tozaagala abazi about your body. Oh, can't tell, oh, can't tell. I wanna be your birthday. Oh, china wolofu. Ontambuliranga china wolofu. Ah, china wolofu. Kyova olabanga ndi musanyufu. Oh, china wolofu. Onvimbiranga china wolofu. Ah, china wolofu. Kyova olabanga ndi musanyufu. There's something about your body. Hey, hey. Anyumidde njagala nkulabe buli kadde. Nendozolera ne balowooza ntamidde. Bw'oyagala kunaaba amazzi bakuwe. Bw'oba toyagala bakuleke. Bw'oyagala kudoola gosita kuwe. Bw'oba tozaagala bazireke. Kinnawolovu. Ontambuliranga kinnawolovu. Ah, kinnawolovu. Kyova olabanga ndi musanyufu. Oh, kinnawolovu. Onvimbiranga kinnawolovu. Ah, kinnawolovu. Kyova olabanga ndi musanyufu. Kinnawolovu. Onvimbiranga kinnawolovu. Kyova olabanga ndi musanyufu.
Play the music the moment is calling for, whether it's turning up the party or winding down to relax in the evening. Curate the day's soundtrack with ad-free music listening and offline downloads on Spotify Premium. Tap the banner to learn more.
Mash up the hula, them dead empire. Nando love. Nafunye pologoma, olunda bane uluguma. Zenine pologoma, olunda bane sanyuka. Ene pologoma teya muto, etekala fukupilo. Bwenda bange kole fujo, emanyo bukono buto. Cheyo ya chenji wa mama, ewange yafuka mwana. Sijira yana kuwapana, kaste uluguma. Empologometa ya mudo, 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 kaste uluguma. Lioness, lioness, Gampita ba king of the jungle. Lioness, lioness, where are you? We gonna light up the candle. Now we're choosing a bailado. Semuita king of the jungle. Kubate tulina unarango. Bakuchido chonga mvimbera. Yekwe yangonde zembera. Nabaya yetu bavimbera. Emubilo to basinga. Empologometa ya mudo. Kaste uluguma. Empologometa ya mudo. Kaste uluguma. Pologometa ya mudo. Nafunye pologoma, olunda bane uluguma. Zenine pologoma, olunda bane sanyuka. We gonna light up the candle. Now we're choosing a bailado. Semuita king of the jungle. Kubate tulina unarango. Cheyo ya chenji wa mama, ewange yafuka mwana. Sijira yana kuwapana, kaste uluguma. Empologometa ya mudo, 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 kaste uluguma.
Wananga temperature touching and the have a PC. Diggity dam, diggity dam, diggity dam,
njagala banywedde empale bazisibira mu kifuba basitulente omwana wamusomya bamulette ewe mwate olerete I got your love tonight, my body got to wine omubiri gwo kusembeze ku gwange niweddembe njo uweddembe ichani wenda owange niwe sewe yumombi niwe sewe niwe haba niwe sewe niwe yinda highway sewe haba niwe sewe niwe yinda highway sewe iyekese sambo onomuhana we sambo handa ulo lugambo ewe nomonya kawule bigambo kagobako gwalina omusekuzo kabampane bebitewo kankwakala ebisema yokunuma wanula 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 walioya wanula 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 walioya wanula 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 walioya wanula 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 walioya wanula Oba hinama hina kalino omwicha niwo mulaye wahono manukhuda hamu ande bahaye onobo busingala hiya haye kamaye ahwire mungobe fe behoye mama papa bahe behoye digidi dam yanze yafuna musamya ne bamba ande abasama bosi bahola ane byubirusa babyajeja embusi yamakoya hola anti ndetire buli sindu siwasaba oma bayale oha ulali chana bagwe basama bagwe bamuno bahana Catalan condo my darling enoba kunyumizo ai mbuba kwetanira bai mbune exi woya kugwadalu kwe kubayirize njai leka tova no ku wifi tongamba be goodbye love you can get a change kwe kutya kuba lonely ngabinsaye njagala kuwe nokoza vamwe byo byewekoza renkunonya tewebuza chicho tyanga nesuza nobugero bugondo ntambula ku hati ontuse ne ku hedi onyonyogera back ondabikira ku face can I be your baby can I call you daddy can I be your somebody can I be your baby can I call you daddy can you be my somebody can I be your baby can I call you daddy can I be your somebody no mutachira bandi mula already can you be my somebody njagala onkotenga kabangata okakwange mami agule mwamata yekwe masanda kwe yakwata nutata tweyagale paka migongo kweweta where you are the type that I die for the passes on the dime that I die for let nobody bribe you if you done your crystal mobile njagala nompaka baby girl tupepe yekwe gambanga daily payer kwe wajja nebyembulamu wandiba wanyikira nnyo beyond repair kutambula ku heart kutuse ne ku hedi kunyonyogera back ondabikira ku face can I be your baby can I call you mommy can I be your somebody can I be your baby can I call you mommy can you be my somebody can you be my baby can you call me daddy can I be your somebody no mutachira bandi mu love already can you be my somebody enoba kunyumizo wayi mbuba kwetanira abayi mbone exi oya kugwadalu kuwayirize njai leka tova no ku wifi tongamba be goodbye love you can get a change kwe kutya kuba lonely ngabinsaye njagala nkuwe nokoza vamwe byo byewekoza renkunonya tewebuza chicho tyanga nesuza nobugero bugondo ntambula ku hati ontuse ne ku hedi onyonyogera back ondabikira ku face can I be your baby can I call you daddy can I be your baby can I call you daddy can you be my somebody can I be your baby can I call you daddy can I be your somebody no mutachira bandi mu love already can you be my somebody can I be your baby can I call you mommy can I be your somebody can I be your baby can I
Okay, are we back? Okay. Great is here, Jacob is here. Okay, cool. So the topics remaining are on kinesis and also step functions. So just getting started about kinesis. Sorry. So we want to collect, process, and analyze streaming data in real time, and that is where kinesis comes in handy. So we can ingest real-time data into AWS, process that data, do some analysis on that data. And over here, we have like 4 different versions of kinesis. So we have the kinesis data streams, whereby we are capturing these data streams. We have the kinesis data firehose, the KDF, to load streams into AWS data stores. We'll see that in a moment. The kinesis data analytics now has changed the name to AWS managed service for Apache Flink. So yeah, for correction there. So to analyze data streams with SQL or Apache Flink. So now it's called AWS managed service for Apache Flink. And then we have Kinesis video streams if you want to process and store like video streams. So just taking a look at the whole architecture with Kinesis, there are different things you can do with them. Yeah, the first one, you can collect, process, and analyze streams in real time. And you have the flexibility to choose the best tool that suits your requirement. You can do some ingestion of data and load those data into like AWS data stores like S3, and then further use that for machine learning, analytics, and whatever you want to do with it. You can perform some queries on our data streams in real time. And then now we are trying to run like stream processing applications using SQL, using Python, using Scala, and so on. And you don't have to wait until all the data is collected before you do the processing of that data. And yeah, Kinesis video streams is just for collecting video streams. And now there you can think about things like the camera feeds and so on. So I'll share more links about Kinesis. But over here, I'll do a focus more on the Kinesis data streams and the Kinesis data firehose. So just an overview of how the Kinesis data streams works. So the first thing, for you to get started with the Kinesis data streams, you have to create the stream itself, and you have to specify the number of shards that you're going to be used. So we have the stream, you can think of it like the river or something. And then the shards, the number of shards that are going to be used. So what exactly is a shard? A shard it's just a sequence of data records. Uniquely identified sequence of data records in a string. So for example, over here, within this specific shard, we have some limits. A stream can receive like 1 megabyte per second in each shard. So that is ingestion. And each shard has a limit. This is the read limit. Whoever is reading data from this stream, like whoever is consuming. So we have like the producer, sending data into our stream. Our stream has different shards. Each shard represents a data record, like a unique sequence of data record. It can ingest like 1 megabyte per second and can push out like the read limit for the consumers is 2 megabyte per second for our applications. So the total capacity, if we think about the total capacity of our stream, is actually like the number of shards, the sum of the capacities of each and every shard. So if you need to like process something like let's say 10 megabyte per second and so on, then you might have to put around 10 shards in that case. So that is it. Then the purpose of the shards is to just increase. You can increase it or decrease it, scale it depending on what your stream needs or depending on the number of megabytes per second you need to process within your stream. So some of the keywords you are seeing over here, we have the producers. The producers are going to put records into our data stream. A producer could be C2, could be a mobile client. It could even be an on-prem server. Common producers, IoT devices, because they produce lots of data within seconds. And then you can send data such as logs, especially logs, infrastructure logs, application logs. Those are the type of data you might be thinking about. For example, the click stream data we are getting from our web application, our marketing data feeds, and so on. And then we have the consumers. So shards hold the sequence of data. The consumers read the streaming data that the producers generate. Consumers too could be an application running on EC2, could be an application running on Lambda. And for example, if it's an application which is running on EC2, it will need to scale as the amount of streaming data is increasing. So if this is the case and you're using EC2, then that means that you're going to run your application in an auto-scaling group. So that is going to scale depending on the number of messages or the number of information coming in to our shards. And another way to like write our consumer application is now to use the Lambda way, which you can use to run code without provisioning or managing servers. And there can be more than one application processing the same data, which is in the stream. And now after that, we need to store the results of our application somewhere. So in this case, we can send data to Redshift for analytical processing or lab. We can use S3, maybe we want to build data lakes from there. We can use DynamoDB for NoSQL storage. So here now you can go ahead and store the results of the consumer application. So I'll just share some more links on chat on this. So like what you can do with Kinesis data stream. So I'll just share lots of links from which I haven't shared yet. So you can save them somewhere and review them. Okay, so that is it about Kinesis data streams, and you can see the whole architecture I was talking about before. We have the producers, could be our applications, clients, the SDK, Kinesis agent, send data, and you can see 1 megabyte per second for ingestion into each specific shard, or 1,000 messages per second per shard. And then for the applications or the consumers which are reading, they can read in 2 megabytes per second per shard on all consumers. And you can scale the number of shards if you want to scale the number of like the megabytes per second for each input or the number of messages you're going to get into Kinesis data streams. So some things to know, retention. You can retain your data in your stream between 1 and 365 days. You have the ability to reprocess data, replay data. That is something you can get with the Kinesis data streams. And once data is in Kinesis, it has some form of immutability. It cannot be deleted. If we are sharing like the same partition, the data is going to go to the same shard. And we have different producers, and we also have different consumers. And from the different consumers, you can even write your own consumers using the Kinesis client library or the AWS SDK. So that is it about the Kinesis data streams. We do have different types of modes that you can use, the provisioned and the on-demand. I think these are similar like for what you even see with the EFS capacity modes. Provision mode, you know exactly how many shards you will need. You know exactly the amount of data that will be coming into your stream. So you choose the number of shards and then you scale manually. So if you know these concepts, then you'll know how many shards do I need, and you pay per shard provision per hour. And the on-demand mode, because it's on demand, you do not know the capacity coming in. So they do like a default capacity provision for you. So like 4 shards are going to be created, and then it's going to scale automatically based on the throughput. So that is on demand versus provision. Provision, you know, so you choose how many shards you're going to need for your application. On demand, yeah, we scale on demand basically. About security on Kinesis data streams. So of course, IAM policies, you can control who has access to your Kinesis data streams using IAM. Encryption in flight is available. Encryption at rest is also available using KMS for our data. You can do client-side encryption and decryption of your data if you want to. And if you want to access Kinesis within a VPC, you can utilize the VPC endpoint. You can see how it's set up over here. For example, this EC2 instance is in a private subnet. And you need to send data or access data from Kinesis. You can utilize the VPC endpoint for that. And then monitoring is available using CloudStream. So that was Kinesis data streams. Kinesis data firehose. So Kinesis data streams ingest streaming data and do some processing in it for it. And so we have the producers and the consumers. With the Kinesis data firehose, we are processing data in near real time. It's not real time. And with the Kinesis data firehose, what we actually thinking about is loading the data into some data stores. So with the Kinesis data firehose, we can send our records either to S3, Redshift, OpenSearch, any HTTP endpoint that you own. And we even have like integrations with that party providers. For example, the likes of Datadog, if you are doing some monitoring, New Relic, Splunk, and so on. So we have all those integrations available with that party providers. So how do we work around this? So of course, there are still data producers who are sending data to Kinesis data firehose. And we do some bit of processing, not processing in the way like Kinesis data streams does it, but you can do some things like batching data, compressing that data, combining that data, and the firehose work is to write that data into the destination, which could be any of these. And now, from our destination now, we can send that output somewhere else where we process that data, do some visualization, integrate with business intelligence tools after there. So you can see the processing is near real time and not real time, as in the Kinesis data streams, where data is ingested and processed. Here, data is saved somewhere first and then processed later, do some processing later. So that's why we call it near real time. So that is the Kinesis data firehose. OpenSearch service for search capability. So it delivers OpenSearch APIs. You can do some real-time analytics capabilities and so on. So that is it. And this is also, yeah, like a whole diagram or architecture of how the Kinesis data firehose work. So you can see, for example, even Kinesis data streams can be a producer to send the record into the Kinesis data firehose. And now applications, client, SDK, the agent, IoT, all those, we send data into Kinesis data firehose. From Kinesis data firehose, we can do some batch. So you saw the capability of Kinesis data firehose, like doing some batch, doing some compression of that data, and loading it into data stores, which could be custom destinations like a HTTP endpoint, AWS destinations, or a third-party partner. We can also send it to do some data transformations into Lambda and then load it, or we can send all that data into S3 for just backup applications. So that is the Kinesis data firehose, fully managed, can send data to all these sources we have mentioned. We pay for the data which is going through firehose, near real time, buffer size minimum of 1 megabyte, and then you can do some sort of processing where you change the data format, do some conversions, compression, transformation of our data within the Kinesis data firehose service itself. And if you want to do some custom data transformations, you can utilize Lambda from this like architecture which I have showed you, and you can send all data to a backup or failed data to a backup in S3 from Kinesis data firehose. So what is the difference between the two streams and the firehose service? Streams ingest data, firehose loading the data into storage or third-party services. So you can write some custom code on the producer or the consumer with the Kinesis data streams, but Kinesis data firehose is fully managed for you. Common exam question: real-time versus near real-time. Kinesis data streams does real-time data processing. Kinesis data firehose is near real-time. That means that there is some delay. This is fully managed, so of course, it's automatically scaling. It does not store data. It sends data somewhere else. It loads the data somewhere else. You cannot replay data in Kinesis data firehose. But in streams, you are the one who is managing your own scaling. It's like you're provisioning your own clusters, so figuring out your shards and so on. The data storage on the stream, you can set up from 1 to 365 days, and you can reprocess or do some reprocessing of the data with Kinesis data streams. So in the exam, keywords: near real-time processing versus real-time processing, especially remember that when you'd go for a service over the other, but you can use both of them together, from streams to firehose to the storage service. So over here we have like an analogy that is used to show like how you order data into Kinesis. So we have an example over here. We have like 100 trucks. That is like the data that is coming in. Truck 1 to like 100 on the road, and they're sending like their GPS positions regularly to S3. And you want to consume the data in order for each truck. So you don't want, like, you want some sort of ordering so you can track their movement correctly. So how are you going to send that data into Kinesis so that you specify like the ordering for each specific truck? And the answer over here, yeah, the answer is available. You're going to use a partition key, which has the value of the truck ID. So that means that the same key will always go to the same shard, and it will be easy for ordering. For example, we have only 3 shards available. Truck 1, all data about truck 1 will always be going to shard 1. All data about truck 2 will always be going to shard 2. All data about truck 3, for example, can also go to the same shard 1. Truck 4, like shard 3, and so on and so on. So if you want some sort of ordering, or you want like, yeah, you want to consume the data in order, you're going to use the partition key to send that data, so that every data which has the same partition key will go into the same shard. So ordering data, for example, you saw how we can integrate like Kinesis into SQS and so on. So let's see Kinesis versus SQS ordering. So we start with SQS ordering. SQS standard, we don't have any order, we know that. In SQS, first in, first out, messages are consumed in the order they are sent with only one consumer. So for example, over here, we have our SQS FIFO queue. So the last in and the first in, for example, over here, like auction B1 will go somewhere over here. That is if you have not set up batching. But if you have set up like different groups, then they will go in the different groups they are in and processed in that specific order. So if you want to scale the number of consumers, but you want the messages to be grouped, you can use a group ID in SQS. And that is similar to a partition key in Kinesis. So the partition key is kind of saying this is one group, put them together. So with the FIFO Q2, you can set up depending on the group. So for example, this is group A, this is message group B. And for example, message group B went first. The first batch will be consumed, but in the same order of the items in that group. So that is for SQS. For SNS, not SNS, but for Kinesis ordering, we are going to use partition keys and not the group specific IDs. So if we assume we have 100 tracks again, 5 shards and 1 queue, like one SQS FIFO queue, how they are going to work. So if you have 5 shards with the Kinesis data streams, you'll have 20 tracks per shard. I hope you remember, like, so if you have like 5 shards over here, then, and we have 100 tracks, they'll be like 20, 20, 20, 20, 20, distributed between each shard. Tracks will have the data ordered within each shard. And the maximum amount of consumers we can have is 5. So who is consuming from our Kinesis data streams? And we can receive up to 5 Mbps of data. Why? Remember, a shard processes like 1 Mbps per second for each shard. So if we have 5 shards, then the throughput we are getting, maximum throughput is this. But for SQS FIFO queue, same ideal scenario. So we have 1 queue. That means that we'll have like 100 group IDs if we want data for each track to have its own like partition. So we are replacing partitions with the specific group ID. And you can have up to 100 consumers due to the different group IDs that you have. So you can say like consumer 1 should process data from track 1 and so on. And remember, it's FIFO, so you have a limit on the messages per second which are going to be in that queue. So you have a limit of 300 messages. And also if you are using batching, 3000, just from what I mentioned from SQS. So difference between SQS, SNS, and Kinesis, now at a high level. SQS, we pull data. SNS, we push data to the subscribers. Kinesis, we also pull data. So the consumers of our stream, I go back to this diagram. The consumers are also pulling data. It's not like data is being pushed to them. They are also pulling data from our stream. Okay, data is deleted after being consumed. I explained that. You can have as many consumers as you want, like multiple nodes consuming the data. You do not need to provision throughput. This is scales automatically. if you want ordering, you use FIFO queues, and you can do the message delay. I think I showed you that in the demo. So you can specify a delay of up to 15 minutes for the message to be available within the queue and be processed. SNS, multiple subscribers up to 12 million plus. Data is not persisted. Once data is delivered, it's delivered. Publish subscribe model, you can have up to 100,000 topics. Also fully managed, like serverless, you do not need to provision throughput. Integrates with SQS if you need a fan out, like the demo we did. And you also have FIFO capability. Kinesis, we pull data, same like SQS. You can do a fan out, enhanced fan out to push data to multiple consumers. Like here, we could have multiple consumers from our Kinesis data stream. You have the possibility to replay data. That is Kinesis data streams, not Firehose. And this is meant for real-time big data analytics. And if you want to perform some ETL, extract, transform, load, we can do some ordering at the shard level. How? By using partition keys. And you can set up expiration of the data between 1 to 365 days. And you have different modes. Provisioned if you know how many shards you'll need, and on demand if you don't know. So you want AWS to handle everything for you. So I can just do like a quick overview, not a full-scale demo on how Kinesis works. So just a minute. Okay, so over here, we just create a Lambda function that will act as a consumer from our Kinesis data stream. And then we trigger the function from the data from our stream. So it's so simple. And then you can also monitor the process from CloudWatch. I won't be monitoring. So we create a Lambda function, create a Kinesis stream. In this specific settings, we have set up like some code to run to just put data into our Kinesis data streams. And then you can monitor what is happening within CloudWatch. So just to get started, we'll go ahead and create our data stream from Kinesis. Okay, and you see like the name of Data Firehose has even changed. It's Amazon Data Firehose. Please put that in mind. No longer Kinesis Data Firehose. And also Kinesis Data Analytics is now called AWS Managed Service for Apache Flink. So you can decide what do you want to create. So for me, for example, it's the Kinesis data stream. And then I can give it a name. Lab stream. And then you specify the capacity. Is it on demand? You want them to handle this for you, or provisioned? Okay. My camera is messing up for some reason. I don't know. But we'll just continue. Okay, I'll just turn it off. So we have on demand and provisioned. If you choose on demand, you can see everything is managed for you. If you choose provisioned, you have to specify the number of shards you want within this stream. And you can see all the details about the write capacity and the read capacity. So I'll go with on demand. Okay, I'll go with provisioned. So I choose just one shard. So provision shards, I'll just choose one. You can see maximum available is 6,000. And you can request a quarter increase if you need more than that. So I'll go ahead, create data stream. And after about 10 minutes, really, should be around 20 seconds, you should see that the data stream has been created. Okay, cool. It's active. You can see the data retention period is 1 day. You can change that and so on. So the next thing I need to do is create my Lambda function, which is going to do the processing. So that will be my consumer for the data within my stream. So I'm going to create a function, but I'm going to use a blueprint, one which is used to like consume data from Kinesis. So the blueprint will be Kinesis. I think it's this one. Processed records sent to, what is the diff? Okay, this one is for Python. Yeah. Process the records sent to a Kinesis stream. And the function name says Kinesis records. Existing role. Lambda basic execution. And you can see the function code, what it looks like over here. So print received events from like Kinesis data streams, and it's going to print for us like the record that is it has gotten from our Kinesis. So it's very simple one. And then the trigger in this case is Kinesis. So I'm going to select the stream that I have created. You can specify an optional consumer. I won't do that. So I won't activate this trigger. I'll activate it later, just to do some testing on it first. And what else? Batch size, maximum number of records. I'll just say 10 and create my function. What did I do? Okay, let me try again. Blueprint. Okay. Is it that one? No. Process records. Process records sent to Kinesis stream. My function name is process Kinesis records. Lambda basic execution. Okay, I'm not sure why it's failing, or it's the region. Dun, dun, dun. Kinesis tree. I'm trying to look if there is any older version. Can't find. So might be the runtime that I'm not allowed to use in the lab. So yeah, unfortunately it didn't work, but what I'll do is I'll share a link to a tutorial that you can work on because of time. So I'll share this link on chat from AWS, which is kind of similar, and then I'll solve this later. So you create like the role that is going to be used, and then I didn't want to create the whole function myself, but you have like the function which you can use like for processing the record. So yeah, I am familiar with Python. It's similar to the one that we have seen before, the one that was automatically created. So you create like a lambda function from that, and then you test the function with a record, some sort of kinesis record, and invoke that function. So from a specific string. So yeah, when you get time, you can test that and see how it works. So it's similar to what I was trying to achieve. Seems like my permissions are creating some sort of issues. Okay. Sorry for that. Wanted to show you how to integrate that, but I'll see if I get some time at the end, I'll also show you how to work around that. Yeah, so that is kinesis. Any questions on kinesis so far? None? So we good. Okay. Then I'll wrap up with step functions. Step functions. Okay, cool. So with the step functions, you want some form of orchestration. So what is an easy way to orchestrate multi-step functions if you have multiple things that you want to do? And this is especially helpful when for example, your company is trying to re-architect your monolithic applications and trying to decouple them into very individual functions or service. So how do we coordinate these functions? For example, to go through a specific order of stuff. So that is where the step functions capability will come in handy to coordinate multiple workflows. So how does it work? Modern applications, it's very common like for them to have multiple services, multiple components. And the more the application grows, the code that you have to write to coordinate also grows. We have like an increase in the code. So with step functions, what you are getting is we want a way to focus on defining the interactions. So my pen. So we want to define the interactions of the services rather than figuring out how to integrate all code to work together. So what you're getting over here with step functions is some form of integration. So you are coordinating microservices using visual workflows. and it can integrate with multiple AWS services, Lambda, ECS, EKS, Fargate, DynamoDB if you have storage, SNS, SQS, and so on and so on. And it permits you to step through the functions, and that's why it's called step functions. Step through the functions of your applications. It's going to track each step, and you can also get like error catching in case one of your functions or one of your steps fail. So a common example like of a state machine, because with step functions you're building a step machine, and a state machine is just like an object that has a number of operating conditions that depend on the previous condition to determine an output. And an example of a state machine is actually a soda vending machine, because this machine is going to start in a specific state. In the operating state, for example, waiting for a transaction. And then that moves to the soda selection state when someone adds money. And after that, the machine moves to a vending state where it's going to deploy the soda to the customer. And after the completion, the state returns back to the operating state where it's waiting for a transaction. So that is exactly like an idea of how step functions will work. You can create and automate your own state machines within the AWS environment using like the Amazon state language, we'll see, JSON based, and I'll share more like documentation on like the state language and so on. So an example over here of a step functions workflow or what you can build. What is a state? So a state is like just any element within your state machine. So this is like the whole workflow, the state machine of how it's going to work. And a state could be, for example, the first one, which is look for the customer ID from DynamoDB table, generate a reference number, and then record that transaction into another DynamoDB table. If it's a success, end the workflow. If it's a failure, notify your admin through Amazon SNS. And you can see we are creating like a whole process where all these services or microservices are integrating together. So like with a state machine or with the step functions, we can do the following. Like we can create a task. A task is like do some work in your state machine. For example, look customer. We have the choice state. Make a choice between this and this. And that is different from the success or failure. A choice state could be either generate a reference ID or do this other thing. So make a choice between different branches to run. And then we have the fail and succeed state. Like, for example, this one. You can stop with a failure or a success. We also have the pass state. Pass its input to an output. Like pass whatever customer ID you got over here to some other output. We have the wait state, where you want to delay for some period of time. So provide a delay like for a certain amount of time or until a specified time or date. Maybe you want to wait maybe 24 hours before you do this, or and so on and so on. We do have the parallel state, begin parallel branches, whereby you want to do two things at the same time. For example, we could start, look at the customer ID, generate a reference number, and also notify someone else at the same time. That is parallel. And we also have the map state if you want to dynamically iterate through different states. So yeah, that is it about step functions. And when you create like a workflow, we have two types. We do have like the standard workflow, and some things you need to know. Maybe I can just use yeah. So we do have like the standard workflow and also the express workflow. So the standard workflow, because express, you know, it's like short running workloads. Standard workflow is for long running workflows. maybe the workflow might take like a long time to run. These workflows can actually run up to a year, and you have full access to the full history of how the workflow has been running for up to 90 days. So you get like logs on that. So that is the standard workflow. And then if you have like some event-driven processing workloads, for example, you are trying to do some IoT data ingestion, streaming data processing, and so on, integrating with mobile backends, we'll go for Express. So this is for short running type of workloads. They can run for up to 5 minutes. So very short, by 5 minutes, the whole state machine will have run and completed. So that is for the express workflow. So depending on if your workflow takes more than 5 minutes, or whatever you're building will take more than 5 minutes to run, then you're going to use the standard workflow. Okay, so that is basically it. In this example, you saw it was like a post request. The client completes a transaction which sends a post request to the API gateway, and the API gateway, remember, event driven. This will create an event that a post request has been made, and the event is going to start our step functions workflow to record the transaction in DynamoDB, move through each of the states until it completes the specific state. So this is the language we use to develop our state machines, the Amazon States language. It's actually JSON based, as you can see over here. Structured language to define your state machine. And a state machine is just a collection of different states. Like you can see here, we're saying that start at this state, and this state is a task to maybe run this start lambda function. And then after that, what is the next thing I need to do? Do the final state. And the final state is also a task to run the second lambda function. So that is the Amazon States language, and I'll share documentation on that. So I hope my final demo runs correctly. So
Pauline, there's a hand from Jacob.
Jacob, please come in.
Yeah, so maybe the question I had around, there was that texture where you shared around the step function. I just needed to understand, do you need to specifically use Lambda for it to send a SNS notification, or you can go in Event Bridge and then you maybe set up for a failed state, like, and then it sends the notification automatically?
You can do whatever you
Okay.
want. So it's just,
Okay.
this was just an overview. You
Okay.
can integrate with literally anything, certain integration you want.
Okay.
Yeah.
Okay. All right.
Cool. So I have my last demo. Hopefully it will work correctly and not disturb me. So this is it's more of a gaming website available. So Test the Capital, it's a guessing game. So this is the website URL that we have available. For example, let me say create a new game over here. So let's see. So it's going to take a few minutes. Let me hold on. Well, it's starting like a server on the back end. Okay, so while it loads, So it has a problem I wanted to show you, but just giving you an overview about the environment that we have available. So here we have like the code of the front end and so on. We have the backend code of the Python file and so on over here. So I want to check the file that we have available, backend. So there is this file I need to edit. That is when my game has already started. It should give me like a specific error. And over here, I need to specify like, so it just contains information about my trivia game, the DynamoDB table that it's going to use, the step functions. So for example, when someone starts the game, which step function is going to be basically executed or started, and that is what I wanted to edit over here. So let me hold on and wait. So yeah, I'll just copy the code over here. So it's going to get the state machine and start it whenever it works. Oh, this game is not opening. Anyway, just to show you an example of the step functions that we are thinking about in the background. So let me open it. So we do have this state machine that you're working with for our game. Okay, and this is the definition of what the state machine is for a specific game is. So it starts at a question and okay. So it says that, so there is a type over here that is a specific state. So the type is, for example, succeed. So if it succeeds, we move on to the next state. So we have a true available over there. If it's true, we go to next state, which is game over. That is, if someone has already chosen the correct answer. So we have different types of tasks that are happening within our state machine. For example, over here, we have the choice state, which is a question. So over here, question wait or wait. Sorry. Where did I take my diagram? Okay. Yeah. So like starts with a question, wait for a few seconds, and then we start, it's just guessing the capital. And then we have a lambda function that is being invoked to calculate the scores. And then we have a choice state after it's done, if the game is over or if it's not over. So if the game is over, we go to the succeed state and end the game. If the game is not over, we do some iteration, we go back to where we are asking the question and see if they are going to guess the correct capital. So this is how like the state's language is going to be looking like. I wonder why this is taking too long to load. Okay. So you can go ahead, start an execution from here and you specify the input. But if you don't specify it, like from my code, it should be started exactly by like our backend or our game over here, which has refused to load, unfortunately. I don't know, it's taking too long. And like from here, actually, when this is executed, you'll start seeing like colors, like green, if it runs successfully, red if it failed. We have like in progress if it's blue. So over here, it's like very easy to troubleshoot, especially when you go to executions, start a specific execution, which from my code should be started automatically when, our game should start. And you will see that map of where exactly something failed. You'll see exactly if it's the Lambda function which failed and you can easily troubleshoot. You'll see a task if it has been cancelled and so on. So like I can share a screenshot of what I was expecting. So let me paste this on my notepad. Okay. So this is like what you would see apparently if our execution works well. So it starts from Lambda and it was like green all the way to the game over. And you can see the different colors, like blue is in progress. If any step failed over here, it will be a red and all the other steps will be cancelled. There could be a caught error and the green is succeeded. So that is basically it about the step functions. And you can see like when you build your own state machine, when you do a definition of your state machine, you can also do it like, let me see if I can edit this. I don't know if it will allow me. So you can say like, you can specify everything using this specific workflow that you have over here. You can see all the, oopsies, enter. Yeah, you can see all the services that you can integrate. Like literally majority of the services are available over here. So it can either invoke a Lambda function, I can publish directly to SNS. So even if you don't need that, like Lambda functions which will communicate to SNS, so you can, my mouse is doing its thing. You can choose whatever service you want and just, for example, add that into your state machine and configure it correctly, and it will automatically write the code for you. So it's just for you to edit. What is happening here? Escape. So yeah. Oh God. So it kind of brought something here which I don't need at all in my diagram. Wow. Within 1 minute, we have done all this. Interesting. I'm sorry.
Good job. That is it here now in the process.
Interesting. Within 0 seconds, I have created a very weird state machine. And my mouse is setting. I give up. So it has messed up my whole flow. But, oh God. Yeah, so we have all the actions you can add. You can also do some HTTP APIs if you want to connect to a different HTTP API and multiple services. And once you add that, it will actually, if you go, that is the design phase, the code will be updated with all those specific flows you have created. Now my code has a million problems because it somehow automated things I don't need, especially with Glue. But you'll have like your code updated. Now what you need to do is, for example, go here at the resource and change the resource ARN for the specific resource that has to be, yeah, to be like run or executed. So I'll just close this page before it messes up. It creates its whole weird state machine. But that is it about step functions. And basically I'm done with what I was to cover today. So I'll send the floor for any questions. So let me share some links. On step functions. Okay, so I have shared some few links on step functions. You can see like different things about standard bus express workflow. What are the states that we have available? What is the Amazon states language? And also like the state lint. We have the lint, for example, for your state, like the Python one. But now this one is for JSON. You can use to validate if your Amazon states language code is correct. So you can check that GitHub site that I have shared on chat. So that wraps my session up. And if there are no questions, I take it back to you, Harriet.
All right. Thank you so much, Pauline. Thank you, Jacob. I think the rest have gone off. Isaac. Yeah, I think this has been really packed. And I'm hoping I'm able to do this in my free tier, Pauline. They're restricted.
You
I've not
try.
tried it out. No, you want me?
You
Before
try
I start abandoning accounts, when they send a request.
No worries, so long as you have a budget set so that you get an alarm
Yeah.
before you exit it. Yeah.
Plus Jacob
Yeah,
will
so
pay.
thank you so much.
Jacob will
Yeah,
pay.
if I have, yeah, Jacob, please send me your card number as I sign up.
No, I have an AWS account, but I no longer use it.
Did you also
Without even
run
knowing.
away? Yeah, thank you so much.
Yes. Okay.
Yeah. Terras, maybe any communication,
Terras.
Isaac?
None whatsoever from my end. I strongly believe that Pauline has done architecture one end to end for you. We are likely to have Joseph Tete to pick up from MSK on picking up from about MSK on next week, Saturday, and winding us up on this very broad topic that is architecture. So, yeah, I think I hand over back to you, Harriet and Isaac. Isaac, I've not got my document from Darius. I don't know.
Sure, because I was in communication with him today. He had told me that we'll be sending them by midday. If he hasn't yet, let me just touch base with him again.
No problem. Maybe he's compiling. Maybe I'm the one who is impatient, but not seeing my document.
He's supposed to share that same document which he presented yesterday. So there's no any need of compilation. It's already intact. So it was a matter of him just his send button, and you would have received it by now. But as I said, let me remind him and so that he can do that.
The button.
Sure.
Okay.
Thanks. And thank you, Harry, too. I think we can look forward to next week when we host Joseph. Otherwise, Pauline, thank you so much for your support. We truly appreciate.
Bye.
All right, bye.
Okay.
A nice weekend.
Thank you so much.
And we
Bye.
will
Thank
go
you.
to the next week. Huh?
All right.